develop their mouth and their butt. And it'll be this, it's a ball of cells. So it starts from that one, it starts dividing in this spherical shape, in a spiral, and that cavity opens in the center, so it's not a solid ball, it's more like a balloon. And there's a mouth end and a butt end. And that's called gastrulation. That's really important fundamentally to recognize how we're similar, because a lot of organisms will have that gut, but there's not going to be too much in between. For example, if you were to disembowel me, you would see that. Hi! Hey, you made it! We're just talking about disemboweling me and opening up my gut chamber. Welcome. Are you hungry? Please have something to eat.
Oh, you guys
We've got lots of food. No, have some food, please.
Yeah. Is this the eating part or the talking part?
We're eating and talking.
Okay.
So we brought something.
You guys know Mike and Maya?
You do not.
Mike and Maya are very enthusiastic tropical plant people, and they could probably tell you anything about a myriad of tropical fruit trees, etc. They work on several orchards here in North Hilo.
Garlic? Oh, that's garlic.
I dug up a bunch of galangal. I brought it for people who want it because I had too much,
What is it?
Galangal is Thai ginger.
Oh,
Yeah.
I want to take it home just to eat it or plant it or something.
Yeah.
cool.
A little goes a long way.
Yeah.
Yeah, we made this like lychee curry.
Dude.
Coconut cream.
Are you kidding me?
Your coconuts, I think.
Yeah.
Fresh coconut.
Well, it must be good.
Yeah. Sorry,
Well, I'm not going to be offended if anybody wants to get up and have some delicious lychee curry. 'Cause I know I want some.
Okay, hold on.
Please, don't wait.
Lychee curry, and everybody was like,
Please don't wait.
That's really appropriate.
"What do you speak of?"
Leaving off about.
So if we were to
So
disembowel you,
if you were to disembowel me, you would find several of my organs floating, in a sense, with several separate membranes. So that, for example, my liver is not attached to my cavity of my stomach lining. You can take it out, and they're not directly attached. They are attached to other tubes and various vessels. But, for example, in a flatworm, there's just that alimentary canal where they digest food, and then blood, and then skin, and then nothing. So that's just a difference in digestion. So your coelom, seal with a C, refers to blood, and your coelom is also a fancy word for your gut cavity, and that's similar to worms. Because worms don't have like a flatworm where I described it was just digestion, blood vessels, skin, and the outer world. They have another membrane. And somehow these magical membranes allow us another protective coating inside. So from these magical spheres, these floating membranes, like the spheres in the sky, we have another protective sheathing. And this is something that we share with the worms, and it says a lot about our microbial makeup. I'm not trying to say that our feces are as valuable as worms, but I'm just trying to relate to you on a very basic cellular level how we're both air breathers and we have similar gut flora. But worms, of course, are very different. They don't have any bones. They don't chew anything, right? Anybody have a worm bin? Anybody? And how do you feed your worms? Do you just throw a bunch of, your kitchen scraps in there and say, have at it. No, you have to masticate it for them. You have to pre-digest it for them. You have to mash it up because they can only really suck the slime off of things in a very delicate way. So you have to break it down so they can digest it. And it's very difficult. Without teeth, how would we eat? We would need a blender. We would need, dentures or something, right? It just wouldn't happen. So if you are playing out in the yard and you eat your banana and you throw your banana peel and your mom says, hey, what are you doing? I just cleaned up the yard. You just throw your banana peel out there? And he says, oh, well, Yuri said the worms were going to eat it. So I just left it there because the worms are going to eat it, right? And she goes, okay, well, it better be gone. It's like, well, sorry, Mom, it's going to be like 4 days. Well, I won't be looking at that thing for all week almost looking at that banana peel, Because it's going to take those other microorganisms that much time to start slamming it down before the worms would come along and say, all right, I can take a bite of that, So for worms to eat, they have to push out the inside of their mouth, suck a little bit, and pull it on back in. You guys kind of visualize that? I know I can't draw it for you.
I wish you could just like have a video of it. It's so cool. I was watching it today in the garden. It was so cool.
If you can imagine taking your mouth inside out and then pulling things in, that's how worms not only eat, but that's how they move also. There's a few more things that I wish that I could draw for you because I love to draw. But I will just instead try and act them out for you. For example, has anybody ever seen a bird grab a worm that's like halfway in the dirt and pull on it? And they're like really pulling, right? Well, it's not just a little curve that it has in the soil that it's grabbing on there, maybe a little bit, but those worms are slimy, right? How are they holding on so doggone hard? Well, worms are segmented. They have those lateral ridges, right? And it's not just their circular and longitudinal muscles that keep them going in and out. On every one of those longitudinal segments, they have these tiny, tiny little hairs. They're called setae. Very small hairs. You can't see them. When the worm wants to, they can just stick them out and grab on. And they're not going anywhere. You're going to break that worm before those things. Yeah. And kids do it all the time. You're like breaking up soil. You have a big, nice clod. It's nice black organic matter. You're like, yeah, it looks great. We're breaking it up. And there's a worm and it's stretching and it breaks. And kids always ask me, does that mean we got 2 worms? Well, we might have 2 dead worms. We probably don't have 2 live worms. Well, worms have 5 pairs of hearts.
5 pairs?
5 pairs of hearts. But that doesn't mean that you can just sit there with a scalpel and cut them all apart and get 10 worms. You're going to have 10 really unhappy pieces of that former worm. And it's going to be like, you're like, whoa. And you're going to tell your friends, well, I can, scientifically, cut this thing in 4 pieces and get, 4 worms. Like, come on, are you kidding me? You're going to be really upset. It's going to take you forever. There's going to be callousing. There's going to be infections. It's just going to be bad, So everybody has seen this collar on the worm, right? It's very predominant. Even Jess has a little tattoo on a little collar on a little worm. Kind of hard to see. Yeah. Well, you can see it. Anyway, y'all know what I'm talking about. So that collar is also called a clitellum. And it passes from the bottom of the worm up off of the head, and they push it off. So that is the egg sac. That's the worm cocoon. And in a worm cocoon, you can have sometimes up to 7 or more eggs per cocoon. So it's something else I also really like to draw. It's 2 worms getting it on. They're getting real acquainted. They're like, hey baby, what's up? And they're like, you know, they're really enjoying themselves. Nobody's watching, it's dark, everybody's comfortable, they're just like going ham, right? Well, you think to yourself, if I had both sexual parts, why would I bother messing with anybody else? It's like, I don't want to stay at home. It's like, I don't want to deal with anybody. I'm just going to be here. Forget you guys, right? I can be my own kids. But then you think to yourself, I'm just going to be sitting around with a bunch of me after that. I'm going to have to deal with like me. And it's going to be really boring. You know what I mean? Because what are you going to be doing? You're going to be making clones, right? You're just going to be making clones. So they get together because they want to have a little bit more diversity. They say, oh, it's got your mom's eye, you know, and your father's Site, and then if you see him no, really bad. So they get together and they actually exchange their, you know, genetic material. This is actually a really, really bad sign, American sign. I won't tell you what it is. But I'll just pretend it's worms getting together. So they pass the genetic material, and then they have greater chance of surviving in the wild against diseases and things like that. They have genetic diversity so that they can expand their consciousness in one sense. So then they move along, and they pass this clitellum off their bodies, and they push it off, and then you get this little worm cocoon that's like really small. It's like the size of corn or less. And they pelletize them. You can buy them for 25 cents. And you can put them in your corn seeder or your bean seeder or anything else you're using out in the field. And you can, for 25 cents, it's pretty expensive, but if you're having a huge field and you want to just throw a bunch of those in your seeder to put out in the field, then you know you've got X number of worms, you know, in the field. Well, that's a really great idea, except you guys ever not fed your worms in your worm bin? And then you come in and you turn on the lights and, you know, you're like, oh, I just stepped on one. You know, they're like on the ceiling. They're like crawling all over the place because you didn't feed them. They're going to find the food. They're going to go somewhere. So for all these people they're advertising to, they said, I can sell you this worm cocoon, 25 cents. You can put it in your seeder. If you don't have that organic matter in your soil, if you keep scraping and grubbing your field and pushing all that stuff to the outside, those worms are going to hatch, they're going to grow, and they're going to go somewhere else. And you just lost a whole bunch of money and time. So it's something that they don't really advertise, like, hello, you have to like have food there, you know. And most people aren't going to mulch their crops that they're spending so much money to put in their seeder and everything like that. So beyond that, you really have to make sure you have good food available in your field if you're having lots of worms. Now, we take this a little bit further. Where was I going with this? The effects of the vermicompost is what we're all after, right? We don't care about gastrulation. We don't care about setae or all these funny dances. We want the worm poop, right? And we want the good stuff. So let's give you a couple of examples of worm poo and its effects. That's something else I also really like to draw. I don't have an example for you tangibly, which you can see. But I'll tell you about it. If you have an experiment and you have 0% vermicompost, you have regular, soilless, sterile media, something that we buy so we know that we're going to get germination, there's nothing contaminating our seed, right? Control. You get 20%, 40%, 60%, 80, 100%. And you'll kind of see this curve. The 0, you know, it'll be pretty good. It'll be growing. It's not going to be dead. 20%, look pretty good. 40%, you might even have bomb growth, you know, maybe even a flower. It starts to go down once you go more than 40, 50%. Way down. You get to 100%, your plant probably died. 100% vermicompost. Because there's so many plant growth hormones in that vermicompost, it can actually act as an herbicide. Anybody ever heard of 2,4-D, 2,4,5-T, Agent Orange, right? That stuff is 10,000 times the potency of the plant growth hormones found in vermicompost. Auxins. Anybody ever heard of Auxins? Anybody ever bought Dip and Grow from the store? Get your root cuttings going really well, yeah? Well, Auxins are like some of the most common plant growth hormones, and they're present in vermicompost, of course. There's 5. There's auxins, cytokinins, citric acid, ethylene, and gibberellins. Have any ever heard of any of those? Maybe the ethylene one you might have heard of. So ethylene they use for ripening bananas, for example, or like especially when they ship fruits to Hawaii and definitely on the mainland. If you buy a peach in the store here from California, chances are they picked it green, put it in a box, sprayed it with ethylene gas. On the way over here, it'll have ripened up. You get it in the store. It looks like this big, beautiful peach. You bite into it, and it's hard. And you're like, man, I even let this thing ripen on the shelf. Like I thought, I kept squeezing it, and well, I am particular about people coming to my house and squeezing my fruit because then it gives you a false sense of it being ripe. And I have to hide them when people come over. But aside from all that, if you go to these giant plantations down in South America where they have all these bananas, they're not going to do like Jackie and the rest of us that wait for that one banana to go ripe and then cut them, right? No, they're going to let it get as full as possible up to a particular day and then whack them. And they all get harvested, they all get through the whole process, and then they bag them, ship them, spray them with ethylene gas on the way to U.S. markets, or Canada, or Europe, or somewhere. And that ethylene gas helps ripen it. Well, ethylene is also one of those plant growth regulators that's going to help ripen your fruit. In the realm of the auxins I was talking about, there's synthetic ones that you can buy, like the Dip and Grow, indolacetic acid, IAA, IBA, butyric acid, NAA. Those are used to control fruit ripening, right? To hinder them, some of them, to regulate them. Some of them are for rooting, like the rooting compound, the IBA, and abscisic acid is one of those 5 that I named. Abscisic acid is one of these that the plant uses. For example, if I'm a durian tree, I got all my durians, right? And they're growing big and heavy, and then one day they just kind of drop, right? Well, they mostly drop at night. People are really concerned about walking through the durian orchard because you can hit one of these things and you're very upset. It's really spiky. But abscisic acid and a lot of these plant growth hormones mostly come out at night, so they're not affected by the UV rays of the sun. And that's why most durians fall at night. Of course, durians fall during the day too. But abscisic acid, to abscise, is when a fruit falls off the plant. And that abscisic acid helps let it go. And you'll see on that stem of the durian, it's always in that same spot, right? Nobody cut it. Nobody went up there and cut that fruit down. That abscisic acid said, bye-bye, and let it go. And the gibberellic acid, you might have gone through Garden Exchange and found GA3, something like that. There's 70 or something different types of gibberellins. And for example, let's say you have a dwarf plant, a plant that is going to grow very short. For example, I love coconuts. I'm going to use the example of dwarf coconut. So if you look at a tall coconut tree, in 6 years, same fertility, the trunk of the tree is going to be about here. And you'll see the leaf margins are very wide. But a dwarf gene is actually lacking in those gibberellic acids. And so their leaf margin is very short, if any at all. Some dwarf trees, I've seen some here in Hilo, it's a 50-year-old tree. Right here, the same height or less than the 6-year-old tree. Maybe a little bit less fertility. But there are some amazing dwarf genes in plants, and they're all lacking the gibberellic acid. So again, there's all different types of plant growth hormones. There's this whole cocktail in there, and they're all used for different things. So it really depends on what you want for your plant. It's really hard to say, I want this specific type of auxin that's going to help my rambutans all come on at the same time, or my lychee all come on at the same time, so that I can harvest them and get rid of them, and then I don't have to look at that field or go back through there for all of the ones that are ripening again. That's really difficult, because you have to go through your worm bin and make sure you're feeding them the right stocks. So here's an example. There's a farmer in the Philippines, and his name escapes me, but he has a huge operation, and he grows microgreens. He grows all of his seeds, his sprouts, in 100% vermicompost. What did I tell you about 100% vermicompost? It's too precious, right? And it's got all those plant growth hormones that are going to kill your precious little seedlings, right? You spend a lot of money on the seed, and if you didn't spend money on it, you spend a lot of time saving and cleaning your seed and keeping it really well. Well, this guy is feeding all his worms all of the trimmings from his lettuce operation. He's got all these microgreen operations, and he feeds those greens to his worms. They love them, they eat them up, and his vermicompost is far inferior to if he was feeding something with a much higher carbohydrate source like papaya, banana, sweet potato, or any one of those things that has much higher starch content than lettuce. Lettuce trimmings, no less. We're talking like the brown stuff, right? What is it? It's got hardly any nutrition left in it at all. So this guy, he doesn't care, because he can get 100 pounds of vermicompost for like $8. You know how much that stuff costs? Has anybody ever bought vermicompost in here? Somebody please? Can somebody please help me out?
$40?
It's like $10 a pound. $10 a pound. And this guy's getting a 100-pound bag of it for $8. You'll never be able to compete with that, unless you can prove to this guy that he's got a really poor nutrient stock. But he doesn't care, because he's just using it at 100%. If he had to water it down to 20 or 40%, which is the optimal range, then he'd have to beef it up with something else, and then you've got to buy that for something else. Even if it's cheaper, that's one more thing that you got to do. This guy takes his 100% plug with the little sprout growing in it, and his water wheel transplanter, and just goes right in the soil with those. Now, that's a great system. For that guy, that works really well. I mean, I wouldn't have any recommendations for that guy. He's making boku bucks. You know what I mean? Like, he's got a great system. He's feeding his soil.
He's going to like in the soil.
Yeah, he just sprouts them into plugs in the 100% vermicompost and sticks it in the soil. Yeah, that is like a pretty legit system. But if you are feeding it with much more nutritious stock, you might not have the same results as that guy. So you really got to think about what you're going to feed them, because worms are really delicate, you know? You can't just pick them up and squeeze them and shake them and wiggle and say, dance, come on, dance. They're going to be like, hey, come on, man, touch me like that. You got to pat them nicely, you know? You got to soothe them, like, baby, what's up? You know what I'm saying? You got to lay it on them real smooth. You got a little bit of food at a time. For example, let's say you have your composting outhouse, right? You think, yeah, I got my red wigglers, got them in there, they're writhing and wiggling. But you have a bunch of people on the farm, and I'm talking they eat a lot, and they are dumping down that outhouse, right? You are going to kill all those worms. They will all perish, and if there's nowhere for them to go, they will surely perish. You might have a little bit more protein in there for a little while they're dying, but otherwise it's just going to be a waste of money. So the limit for human feces on worms is about like six pounds per square meter. If you have a square meter outhouse, you can't be putting down more than 6 pounds, you know, every few days. How many people
get out a pound every time. I mean, I don't know. So it's something to take into consideration. Also, it's got to be spread out. And anyway, it's something that it's just a lot more complicated, and most people just don't want to get down there and move it. So I can tell you one situation I've seen that works very well for red wigglers, Yersinia fetida, in a composting outhouse. And it's because they had, this was a regular flush toilet. This wasn't like you go into the outhouse, there's a little moon cut out of the door. No, it wasn't any of that. It was, your regular Midwestern grandma's ready to come home, and she doesn't want to have any of that fuss. She just wants to go in, flush the toilet, and say goodnight. All right? Well, if you have that system, and you have that pipe flushing down, and you have it on a screen with rocks, then your worms can live on there. And because you got the drainage from, the flush toilet, it's like a gallon per flush or something. That water's gonna kill your worms if you don't have good enough drainage there. But otherwise, everything's pretty much just gonna sit there, right on top. And those worms are just gonna go to it. So long as you don't have more than about 6 pounds per square meter is a general rule. And I'm sure that most people wouldn't be dealing with that much in a day. But you never know. Just make 2 of them, right? Or spread it out and get more worms. So that was a specific example I saw at Shakina and Berton's farm, at Milk and Honey Farm in Pahoa. You guys ever been there? You guys been there? Yeah. Well, they had her mother come, and she was not going to deal with the outhouse. So they installed this setup just for her, but they didn't want a cesspool or anything like that. They just had like a 100-gallon water trough that they had cut the bottom out of, and to keep they just kept the goats away from there, because the goats kept standing in there. And you open it up, and there it was everything there. The toilet paper was there. It was everything that just went down the toilet, and it was right there. And they were eating it, and they were happy. And I think they preferred the regular outhouse, but whoever was particular was using it. So again, they were happy because there wasn't too much. You can, overdo it. And I've seen Norman Arancon here at UH Hilo. I've seen him. There was experiments where he was almost really excited to see how much he could really do with this, and he had the pig hunters come with all their dog stuff. We're talking buckets of the dog stuff. Ooh, it was nasty. And he made sure he spread it out thin enough. It was about 1 inch, and he gave them about a week or 2, and it was gone. No smell, nothing. And it was just incredible, You could have picked this stuff up. I didn't pick it up. But it was really incredible. I don't know, how nutritious it was. It was probably pretty nutritious. But that's probably the most important thing you have to think about with your worm bin is feedstock, consistency. You've got to make sure that other organisms aren't getting in there. If you start getting the black soldier fly larvae in there, they're just so voracious. You won't stand a chance. They'll never stand a chance against those black soldier fly larvae. They'll eat, 2 gallons of them eat a chicken in 45 minutes or something like that. It's just alive. Well, maybe after it's all plucked or something like that. But they'll get there, So you got to keep a big screen over it or some kind of cover. Can't have it too moist. You got to have good drainage. And consistent feedstock is really, really the key. Making sure that you have a good system, that you masticate it first. You have your bucket where you smash it up before you give it to them. Mix it up with whatever you got. When we first started over there with Norman's worm bin, we were using, like I said, whatever we had. We had shredded paper, and we weren't even getting cafeteria scraps at that time. We were just using shredded paper, and just to get them a little bit more enthused about it, we would take that shredded paper and we would infuse it with all the coffee grounds and the tea bags from the teacher's lounge, which is the best, right? Because they're just throwing it away. So the worms were totally stoked. They're like, oh my God, thank you. Whereas before they're going, it's roughage, it's sharp, they don't even want to wiggle around in here, So then we started getting the cafeteria waste, and then that was kind of intermittent, most of it was the paper plates and things, and a little bit of meat, but we were dealing with that too. And then we started a new system. We would take all the paper plates, all the paper cups, all the scraps from the cafeteria, and we would have a preliminary staging area. Mix it all together, sprayed it down, put a big tarp over it, let it heat up. And then when that heated up, we could turn it a little bit, let it compress, break down a bunch more, because there's so much airspace with all those paper plates and everything. It just makes it impossible for those worms to deal with it. So you have to break that down a lot first. And then afterwards, when you compressed it, there's still enough diverse particle size and moisture for them to have a contact surface area. That is, like, again, one of the most important things in a regular compost pile. And I guess I could say one more thing about compost. My worm bin is my compost pile. And I figure I'm going to work really hard making this worm bin, or I'm just going to feed them and they're going to come to me. That's kind of like how they do in India. They have a very easy batch system. The most infrastructure they have is a little thatch roof to keep the sun off of them. They have a batch system where they bring in all their cow manure, whatever they have is mostly cow manure, and they make a line of it. And then the line next to it is the old stuff where all the worms are at. And they have thoroughly digested that, they have thoroughly eaten it, and they are just about to, run to the store if you don't give them some food. So you put out that next row, and you can come out at night and see them, and they're all making their way over to the new row. And you don't have to do anything but just put that new row there. And then it's ready to harvest, and you can just get that new one going. That's a pretty easy way to go. I don't know if they have any problems with soldier flies or anything like that.
Not that I've seen.
Yeah, generally they have a pretty easy system, but they also have a lot of labor. They have a lot of people that are there, and maybe that's like the most important thing to do. Maybe that's the most lucrative thing that they have to do, and that's fine. That's a great way to earn a living, helping out on the farm somewhere. So that's a really easy way to go. With my compost pile, I just add a little bit, cover it up with some mulch, cover it up with some grass clippings, some weeds that I weeded, keep it going. And if there's enough fluff in your compost pile, you don't have to worry about having fed them too much. Because if you have your worm bin and you lay too much on there, they'll suffocate. They won't be able to eat it in time if you didn't masticate it enough, and it just won't work well. Yeah. So does anybody have any questions? Do you want me to do another dance?
So is your worm bin a constructed thing, or it's just a pile on the ground?
It's just a pile on the ground.
And you just and is it the red wigglers or the earth?
Yes, it's the red wigglers and the Indian blues.
And you introduce them at all, or they just
Nope.
come?
They just come. Yeah. If
You
you
don't
have
have
it
a
there,
or anything?
I don't keep it covered. My biggest problem is the pigs. So I have my compost pile in the fence, and I have one outside of the fence. The one outside of the fence gets regularly turned by the pigs. Unfortunately, when they turn it, they tax me by eating my worms, unfortunately. But there's always going to be more worms. And the pigs eating some worms, I guess that's just a small price that I pay for having them turn my compost pile.
I have 2 questions.
Please.
One is on behalf of children in school gardens.
Mm-hmm.
I've noticed this about the worms here, but not on the mainland, is they flip.
Oh yeah, they jump.
How are they able to do that?
They are so happy. They are stoked on life. And furthermore, what most people don't understand is that most people don't know is that Hawaii has a much higher organic matter content than mainland soils. And you're also thinking about worms that are supposed to be in a cooler climate, they're in a warmer climate. And those red wigglers actually prefer it a little bit cooler. So it's kind of like a fish out of water. Like, I walked in here today, and I went, oh, you know. But Jackie was like, oh, this is crisp, you know. You know what I mean? So Jackie's probably a little bit more, you know, happy to have this than I am. I'm like, oh my God, it's a little crisp in here. So those worms would prefer a little bit cooler than we have in Hawaii. And they have much more organic matter in the soil. Though that's the main difference, yeah. Was that your second question?
Well, I'm wondering more like their musculature, or what makes them able to like lift their bodies off the ground like that.
Well, they have this longitudinal muscle and this circular muscle. And the longitudinal muscle and the circular muscle gives them that wiggle. Yeah, it's like your extensor and flexor. Yeah, like equal and opposite. Except for like a frog, they're really strong extensor, but very weak flexor. So if you grab a frog after they extend their legs, they're not strong enough to break your grip and pull their legs back. Yeah, just an example.
So, worms can eat rocks, I've heard.
Mm-hmm.
Do that through, how do they do that?
Okay, so they can't masticate. Remember, they don't have chompers. They don't have no teeth, but they can take things in. So that's one of those things that it's hard for me to visualize and explain to you because I don't have my board here. I have my board here. I have the whole worm drawn out with all the anatomy and all the weird words that you don't want to know about. Well, the worms also have a crop and a gizzard like a bird. And if you ever ripped open a bird, their gizzard has this plate.
Ripped open a bird.
I'm sorry, that was
Are we just gonna like rip open
a little bit burp. That was a little bit burp.
Gizzard.
So I don't know. Maybe you've seen like a cat rip open a bird before. And when a cat tears into a bird, the first thing they go for is the gizzard because it has all of those greens and seeds and things with all the enzymes in there breaking it down that cats can't do. If cats were to, you know, chew at some grass or something, they would probably bark. They would probably, you know, throw it up. But that's the first thing they go for in a bird because the bird has all those enzymes that are going to break them down. So that's like the salad for the cat in the bird gizzard, right? I know it's kind of gross, but
Gizzards or cat salads.
gizzard or cat salad. I mean, otherwise they're just not going to get it. You know? But in that gizzard, there is a plate. And in Chinese medicine, it's actually a very medicinal part of the bird. There's this very rough plate. And the gizzard acts like this blender. And with the rocks in there, they grind up all of those seeds and kind of make like a little paste poultice smoothie thing. Yeah. And in a worm, they use that. It's a very good question. In a worm, they're doing something very similar, but they don't eat as many like seeds and things like a bird would. But evolutionarily, it serves the same purpose of like grinding up anything that got in there.
I
Yeah.
think of it like the way like fiber in our gut sort of like cleans out our gut. I
Mhm.
think like that grit in the soil as like cleaning out the worms.
Absolutely.
System.
Yeah.
Just like, yeah, so just doing more out of the worm.
Mm-hmm.
And they're probably like that.
Scrubbing the inside.
Do they like hang out on the rock and the rock has the microbes that they start?
Well, there's tons of rocks in the soil. I mean, depending on where your soil's at, maybe it's all rock. But yeah, there's tiny rocks that they can eat. And like I said, it's one of those evolutionary things that they still have. They might not need it as much. You know, like some people say we don't need our appendix as much based on a change in our diet. Worms probably don't need that little rock as much as it's just there and they're probably used to it. You know, they probably don't take in as many. And a lot of birds will die with a lot of those rocks in there. You know, they'll just kind of hang out in there for a long time.
Also, what they excrete is like covered in a calcium.
That's right. Yeah, when they're moving through and they're tunneling through, they have That's another thing that I can't draw for you.
Glands.
They have this along their alimentary canal, their digestive tract. They have these metanephridia, and they are pretty much like their kidneys, but they run along the alimentary canal. And on every one of those segments, like I told you, there's the setae. There's also these nephrostomes, which are like a pore. And those pores excrete that substance Jackie was talking about. It has calcium. And it coats those linings of their movement through the soil. So you could say that that is a waste product from the worm that is excreted out and acts as a lubricant. It's kind of like worm sweat. It helps them move through the soil. It's also really cool because then as they're tunneling through and moving around organic matter and stuff, the plant roots then fill in those little holes, and they say, oh, we have more air, there's a little bit more moisture in here. Plants left, worms left behind some nutrients, some humic acid, those plant growth hormones, a little bit of calcium. Very good point. Thank you for bringing that up. Yeah.
Go worms.
Go worms. Yeah.
Have you ever seen little fire ants interacting with worms in any way?
We
I
did
have
an
not.
experiment in our house.
I have not. We have LFA, and I see them in the soil, and I've never seen them interacting with the worms specifically. But we have chokeworms. I can't stab somewhere without, jumping out with a whole family of worms. Yeah. So there's probably some interaction going on there. I don't know if they're tickling them for some of those exudates or something like that. You know how ants are tickling all the aphids and everything. That's what they do.
Aphid.
Yeah, they milk the aphids. Yeah.
It's adorable.
Yeah, it's kind of evil, but
I think it's adorable.
yeah, I guess they're just farming them, using them up.
So I have a question.
Please.
So say you have like 50 pounds of like really wet, rough vegetable scraps on a weekly basis.
Okay, here we go. Here we
For
go.
example.
What's the like easiest way to deal with that with
Easy.
worms?
I like easy. Well, now, what kind of vegetable scraps are we talking about? We're talking
Like
carrots?
Cabbage leaves,
Because
whole
cabbage
like
leaves-
carrots.
Cabbage leaves are way easier to deal with than a carrot,
Yeah.
because cabbage leaves, they're not as dense, there's a lot more airspace.
There's lots of the airspace goes away really fast with cabbage.
Right,
leaves.
they melt.
They get soft. And
But
melty.
for example, if you chopped a cabbage once, you get vastly greater surface area than if you chopped a carrot once,
Right.
right? And as dense as the cabbage is, as much water that got the carrot and the beet and those other roots are gonna be way more dense. So the easiest thing is if you had a meat grinder, you might be able to buy one secondhand, maybe Craigslist. You got a brand new one, probably be like $300 for like a really industrial one. Send them all through there, and then you'd be able to layer that out way easier with leaves or something else like that. I'm sorry, Sue.
You answered my question.
Oh, okay.
I
Jeff.
was gonna say, so all of that material would, after a couple of days, rot. Like we've seen.
It will be
carrots-
sloppy.
Carrots go bad.
Yeah, they will be
Gnarly.
very wet.
But would the the heat generated from the anaerobic decomposition of like 50 pounds of this waste,
Mm-hmm.
would that actually kill off the worms, or would the worms? be
Yes, if it's
disadvantaged
too
with
thick. If it's too thick, that's why you have to layer it with
product?
something brown, right?
So how much so for 50 pounds does the same like
You'd want it
equation
to
apply?
be, yeah, like at 1 inch,
Okay.
1 inch thick, and however big an area you're,
So you
you're
put your
working
like
with.
wet stuff down and put dry stuff.
And they
dry
would
stuff on
not
top
be
of that.
able to, because that's very rich stock, like we were talking about,
Yeah.
nutrition of your stock, they would probably not be able to eat that in a week, depending on how many worms you had. If you had enough worms,
I'd have to have enough worms.
You'd have
eat
to
it
have
in a
enough
week,
worms.
Because
Now-
next week there's another 50 pounds.
right, but
so.
you would probably be able to build up enough worms to eat that stock after several months of feeding them, and then you'd be able to have a general homeostasis that could handle that if you had the same amount every week.
Yeah.
Yeah. But you have to have enough area, because if you just keep every week on the same pile with not enough worms, they'll
Then
perish.
it's just from a compost pile.
And then it would be a compost
Yeah,
pile,
which is
yeah.
my question was, what's the difference between, is it just the fact that it's one, like this very small layer?
Oh,
that
well,
makes it separate than a compost pile?
well, that's one thing that I didn't say when we all started, is that worms are mesophilic. They're cold composters, as opposed to the thermophiles, the high heat organisms that thrive in the compost pile. So in Kyle's case, for example, if he wasn't doing the worms and he was just making piled and adding on layers and layers and layers and layers, that would heat up. It would definitely heat up. And then there would be a time where, as the heat would kind of stay towards the top, and the bottom would get colder, and that's a kind of what they call a curing process. And in your kind of bar curve, you'll see during the curing process where it cools down, that's when all the worms move in and start doing their work.
Because that's how you know, at least like with the school garden, how we know a compost pile is done when we start seeing the centipedes and the worms
Yep.
and the arthropods.
All the shredders and everything that can't live in that high heat, that's when your Mauna Kea turns to a Mauna Loa compost pile. Yeah. Very good question, Pat.
So I'd have to have like an enormous worm bin.
No, I wouldn't say an enormous worm bin, but worms are expensive. Worms are, anyone want to guess per pound? How much is a pound of worm? Solid worms?
It depends.
$20. Was that the
$20, sign me up!
Was that the $40 figure?
It's like
No.
$40 to $120. depending
Yeah,
on
it
where
can
you
be
buy them
more.
from.
It can be up to $150 for a pound of worms. You got a pound of worms? Baller stuff.
Yeah, on the mainland it's like
Money.
$20.
Yeah.
I talked to a guy that had a vermicompost.
And it depends on
farm.
how much you get. You know, if you're like 1 pound, then you're like, don't waste my time, you know? It really depends.
He was like, worms are $80 a pound in Hawaii? I gotta figure out how to import worms.
Yeah.
Do you think that there's a market there? In the
Absolutely.
state?
Absolutely, there's a market for worms.
There's
I-
a lady in Waikiki who is uber successful selling worms.
Yeah. Do you know what her feedstock is?
I don't
She's
know what
probably
feedstock
she's
is.
probably hooked up with the local farmer, you know.
Yeah.
Get plenty of stock to grow on.
Months or something.
Yeah, Norman used to have a program. He also has fire ants, so he stopped having this program where he would give you a pound of, not solid worms, but whatever came out of the worm bin, you know, there's food in there and stuff too, the vermicast. He'd give you a pound of all that, and in a month, you'd give him a pound back. And if you couldn't make something out of it in that month, you'd just be giving him back the same pound, hopefully not just picking the worms out of it. So that's one technique. If you can sift through there and not get the fire ants, I'm not sure I recommend it, but it might be worth a try.
Yeah, I would need lots and lots of.
Oh yeah, they
My-
love the milk washings. Oh my gosh.
My compost pile now is like 4 by 8, and it heats up like crazy.
Mhm.
So like have a worm in it, have to be like twice that size or something.
Yeah,
At least.
and lots of
Just
worms.
just spread out a week's worth of stuff, only an inch thick.
Yeah, you'd have like a pretty solid continuous flow reactor going.
What about like a hammer mill or something? I just like imagining a meat grinder and having like huge baskets of cabbage and like stuffing them in this little hole this big, you know. Like, yeah, something
Yeah,
where I can
yeah.
just like dump it and it's
Oh, whatever.
At
Yeah.
Humboldt, State, we had a bin that someone made in Oregon that was twice the length of this table,
Right.
and we spread out all of the pulverized food that we chopped and had lots of student help. We chopped
Yep.
it all with shovels, and then there was a filter that you could control the handle on one end, and it sifted out the fines, and you could move out all the fines in a long tray, and scrape it out with another shovel.
That's awesome.
And that was how we handled most of the food scraps.
Yeah.
On a 7,000 canvas.
Because you need to have a way of harvesting your vermicompost. You can't just have you say, oh, I got this great idea, we've got all this stock, and just keep adding it on and on and on. Eventually, you can have a bunch of stuff sitting there, just getting old. You've got to be able to harvest your vermicast.
A worthy project for the welding students at the community college.
Yeah. That's a great project to undertake.
And is like, would the recommendation for harvesting be like having, like we have at the school garden that like, we call it the Worm Hotel, and it's got like multiple stories.
Right,
And
high
so,
rise,
like,
yeah.
always feeding
projects.
into one layer, and once that's done, you take from the bottom, you harvest, and then that
Right.
becomes the feed layer. So like the worms basically move up toward the food and leave behind.
Right, they never know. They're always moving
What?
up. They're
Yeah.
only taking the elevator up.
So it's easy to harvest. Although
Yeah.
I have with the kids before because they're kids and they love it, like sifting through and separating the worms from the food.
Oh, they love it, yeah. They just want to grab all those little worms.
You know, the guy that I saw, his operation in Yelm, Washington, is called Yelmer. It was really cool, but the way he got the worms out of his vermicompost was he had this big like drum screen. It's like a big rolling drum. It's like 20 feet long.
Yeah.
And they dump the it's at an angle, and they dump the vermicompost in at one end, and it gets screened out, and then the big chunks, there's something about the centrifugal force of the thing turning, the like big chunks of compost that didn't get digested by the worms, he has 2 wheelbarrows at the end of it, and the worms always go one direction, and the big chunks always go one direction. And so there's like one wheelbarrow that's like just full of worms, and one wheelbarrow that's like just full of like
That's perfect.
big chunks of organic matter. It has something to do with their weight and
Yeah.
like, yeah, it's trippy. It's like there's like one worm in this other wheelbarrow, and there's like 10,000 in the other one. It's wild.
Fun physics.
Yeah. He's like,
That's
I don't know what to
beautiful.
tell you, but it works.
That's absolutely beautiful. I
How,
want to see
how
that.
can you know how many worms you have? You know, like you're talking about like laying out big, thin piles. Like how would you know if you had enough?
Like a sample.
Yeah, you would only know by doing a little bit at a time.
So is there like a calculation to say like if I'm starting out with an area of so many square feet
Mm-hmm.
and I'm feeding 1 inch of this many
Yeah.
square feet every week, and I have to start with like this many pounds of worms? Is there, like,
Yeah,
an
there
equation for that?
there is an equation for that. But again, it depends on your feedstock. If you have chicken manure, you're doing 1 inch of chicken manure. You're gonna need a lot more worms than if you're doing lettuce. You got an inch of lettuce there.
So just hypothetically, carrots and cabbage and radish greens.
Let me ponder on it a moment. You would need 50 pounds.
Yeah,
I would estimate somewhere in the 3 to 8 or 10 pounds of
That's not
worms.
too bad.
Yeah. It really depends, you know, because if you have mostly carrots and cabbage, you
some sort
know.
of hammer mill or something.
Right, you can have too many and they'll leave. Yeah,
And they'll leave.
they will leave. Yeah.
They're pretty good at controlling their population.
Right, they're good at controlling.
Mm-hmm.
So better to start with more and just have the ones leave that are.
Unless you're buying them for $150 a pound.
Yeah.
If you're getting them at 20, yeah, sure, toss a couple,
If
20 bucks around, you know.
Food, they'll stop reproducing.
Yeah.
And then when they have plenty of food, they'll keep going.
That's right.
How long is their life cycle from egg
That's
to
a good
reproducing?
question.
That's a very good question. I know it takes them about a week to hatch after the phytellum is pushed off, and again, that depends per species. Amount of worms per cocoon depends per species. The amount of time it takes them to become mature and produce clitellum is like several months, but it, just like Jackie said, it depends on how much food you have. There was a really interesting study that I read in this book called Secrets of the Soil. You guys probably heard of this book, Secrets of the Soil. So this guy took a can of worms. We're not just talking any old can of worms here, right? He took this can of worms and he put a tablespoon of bentonite in there, right? And he had another can of worms, talking like a coffee can size can of worms, and it just had the worms with the dirt that were in there. And he let them sit for like 6 months. Nothing. He didn't add water, didn't open the can. It was just what he had left them with, right? And that one can that had that tablespoon of bentonite in it was writhing, exploding with worms. They were all reproducing in there and full and healthy. In the other one, where it just had whatever parent soil was put in there, it was pretty much the same. It was like a cold can. Yeah, and it looked sad. Yeah. So, nutrient feedstocks. Anybody know anything about bentonite? Montmorillonite clay, azomite, probably heard the trade name.
Bentonite or Benton, Oregon. Sometimes.
Sometimes, yeah. There's a huge mountain of it in Oregon. But it's this type of clay that has really diverse minerals and has colloidal particles. So they use it for pottery clay. They use it to make that really smooth. If you notice, like, I remember a friend of mine this time of year, all of her avocado trees are going off and they just couldn't handle it. She didn't have anything to eat it. She was throwing them in her compost pile. There was way too much oil and amino acids in her compost pile. So I was like, well, what do you have? You know, you got weeds, you got like brush, some brush. She had some bentonite. She was working at a clay studio. She threw some bentonite in there. It was like magically better. And those worms, and it like balanced it out, you know. But bentonite's pretty expensive. If you ever go out and buy that stuff, it ain't cheap. So, like I said, it depends on what you got. So it could take you, like your red wigglers grow much more slowly than your Indian blues. And then there's these other worms in Australia. There's this giant worm. Oh my God, this worm is this big, like a hoagie-sized 3-foot worm, you know. And there are a lot of problems with this worm now because they cut down the forest so you can have more rice paddies. And then all these farmers are complaining that the worms are going through and tunneling through and draining out their rice paddies. And then they're getting mad at the worms when it's like, hey, you cut down our forest. We don't have anything to eat, you know? So who are you going to be mad at?
How do we get those worms?
I don't know if you want those worms, man. They'd be crossing the highway. They'd be like, man.
I feel like they'd be like epic like pig battles.
Yeah, there would definitely they'd be like trying to grab it. You know, they're like new bait stations. Yeah. Oh, they're mean. They look like those gnarly lychees at the end of the season with all the brown little bits sticking on them. Ooh.
Oh, so I have another question.
Please.
Speaking of worm growth, so I've heard before that it's not like viable to grow worms for animal feed because they don't like reproduce fast enough. Do you know anything about that? Like using worms for?
Well, like I said, there's some worms that will reproduce better at colder temperatures. We're talking like in the fridge temperatures. You know, mainland worms much rather produce at those temperatures, but optimal feedstock, optimal conditions, you know, you're talking someone that's got their scientific thing dialed in with their continuous fluid flow reactor, you're not going to be able to produce it unless you're feeding like little baby chicks that aren't going to be eating a lot. They just don't make that much mass. You're talking about like Mike will tell you how many pounds a cow can put on in a season if there's that much grass as compared to no grass. Well, that cow's going to put on way more pounds with the same optimal feed, conditions, everything, just because it's that much bigger an organism, you know. The genetics are like fit for that. That would be really, really hard to get that many worms. Yeah.
Is there a native earthworm?
No, there's no native earthworms in Hawaii. Yeah. Coming out of the ocean. You gotta come here, wind, water, wings. I'm not sure that any worm would be able to survive the flight or through the ocean. But there are nematodes that survive in the ocean. I don't think that they would be able to like swim from like Indonesia to Hawaii. Like, yeah, we made it. But yeah, that's another whole subject of worms that we know nothing about. It's like, let's build another telescope. Let's like send rockets into space, and we don't know anything about nematodes in our soil. You know? Like, if you took away all the soil on planet Earth, we're talking every last single piece of sand, silt, and clay, gone. You could still walk on the continent because there's that many nematodes. We're talking millions per cubic gram of soil. It's like, what are we doing? You can see some of these guys are super badass. Super badass. If you go take your little gram of soil, and you have like a coffee filter or something, so a little piece of paper, paper towel, and you bag it up, and make like a little prayer bag like they do with tobacco, and you put that in a Ziploc bag with some water, and you hang it on the corner. have that little bag of soil in there. In less than 24 hours, you will see those nematodes escaping from that little gram of soil through the paper. And you can see them all in the water there. Those are the macro, the much larger nematodes. And like I said, there's like a whole society for nematodes. There's like so much we don't know about nematodes, and it's like, really? You know, these things could be like curing cancer or something. We have no idea.
We have a nematologist coming to the National Farm Symposium.
Really? When's that? October 1st? Oh, I want to go.
First, second, and third.
I met the president, it was a couple of years ago. He came to stay at this farm I was living on several years ago. He was kind of dry, but if you got him going, he was like anything you wanted to know about nematodes. Like, whoa, watch out. Like you didn't want to know. It's like, no, I really want to know. Yeah, I know a couple things about nematodes, but it's nothing like worms. They're totally different. They have a hard exoskeleton like insects. Yeah, I forget the scientific name. Yeah, nematodes, they have an exoskeleton that they shed so they can grow bigger, like insects.
Or like
They're not reptiles.
no, but the same shedding.
Yeah, they shed their outer integument. Yeah. The easiest example I can give to people of nematodes in Hawaii is it's not just those carrots like or beets or something where they damage the roots, or ginger or something where they're chewing at it. Nematodes are so small, you got to look at them with a microscope, and you got to be able to identify their mouth parts. It's got to be really high, like 450 times magnification, to see that little stylet, to see whether they're a piercing, sucking nematode or a good nematode. Good nematodes eat the bad nematodes. And the only way you can really select for that is if you have a thermophilic compost pile. And the compost pile getting up at least 140 degrees, you're going to burn off those bad guys, select for the good guys, eat the bad guys. So it's like, that's what you really want, along with like burning off pathogens and stuff. But let's say you went through a banana grove, and your banana grove is like doing really bad, right? There's trees falling down for no reason, bending over and everything like that. Well, most people know about the weevil that will bore into your banana corm. Now, if your banana tree falls off at the base, that's the weevil. But if your banana tree bends over prematurely, no fruit up there, or maybe the fruit's still green, the whole tree just bent over, there's a nematode that will swim up in there, and as it's swimming up in there, it's laying eggs, and those eggs are hatching. So by the time it gets to about 3 feet, there's so many generations of nematodes that are eating their way and laying eggs through there that it just becomes so weak that the whole thing just can't take it and just bends over. That is a symptom of nematodes as opposed to the weevil. Yeah, that's one of the more common ones here in Hawaii, other than the very easy to notice nematodes with the stylet that pierce and suck on the plant roots. Yeah.
Jackie, aren't our popo ulu bananas in the garden, like, don't they like have a bug in them or something? Is it a weevil or nematodes? Or something else?
Boar. The root boar.
Yeah, it's probably the boar if it's falling over at the base.
Oh, okay.
And there's ways that you can clean up from that. I've heard people using cassava leaves, mulching around their banana with cassava leaves for the cyanide that releases when it's decomposing. I guess they don't like that.
We have cassava right next to that banana patch.
Yeah, it'll probably be much more dense if you like break all those leaves down and mulch them, as opposed to whatever's dying at that time. Probably a lot less cyanide. Well, I'm getting cottonmouth. Anybody have any more questions?
Thank you.
You're very welcome.
Thank you.
Very good.